Yeah, thanks. I'm trying to run the workshop demo, but it looks like it's not similar as the slides. So
There's more information in the workshop demo. Like just because I'm just took splices from here. But if you run Nargo test, it should all run. If not, please file an issue. I'll fix it.
would
But
you like to run now or later?
well, if you go, so I tried to put it into stages. Master on that repo is not going to be what you need to look at. There should be, if you go to the pull requests, sorry, I should have specified that. And like the branches, we have a stage 0, stage 1. Stage 0 is just the very simple big num. Stage 1 then should be our generic big num that is it gonna, I guess we're, okay. Stage 1 is our generic big num that I showed originally, and then stage 2 is gonna be, we actually implemented a big num trait, and then stage 3 will be using metaprogramming to get rid of that boilerplate. So yeah, I wanted to try and split it up so you could see the progression from the initial just very simple big num. Does that help? Any other questions? They don't necessarily have to be about the presentation. All right. Sweet. Thank you for listening. Happy everyone's here. And I'll be at the booth there if anyone has questions you don't want to ask right now. You just want to ask it privately. All right. Thank you guys.
Test, test. BD, 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 BD. As I was told, that's how you GM here in Argentina. Lovely meeting you all, and GMs to all the English speakers like me. I'm Savio, the product manager of Noir at Aztec Labs, and welcome so much to the NoirCon itself. We have had some great workshops today that went through, oh, this is not intended. 1 second, let me make sure that's down. Yeah, resting your eyes are always good. Do remember that though. But yeah, we have had some great talks and workshops today that gone through parts of Noir, next door, parts of Aztec, and also a lot on the privacy community side of things. Leading to the afternoon sessions, I'll be kicking it off with a brief talk, a brief overview of what's coming with Noir 1.0 itself. You might have heard of Noir for the first time. Actually, who here, this is your first NoirCon for you? Is this your first NoirCon? Can I get a hands raised? Lovely, wow, that's a lot, that's a lot. Second time? Oh, quite a few as well. I will skip the third one onwards, but oh, okay. But yeah, despite how many times you have been to NoirCon, welcome to the Noir community always. There are a lot of exciting things brewing, both in-house as well as in the community itself. And so yeah, let's just dive in. But before going into the actual 1.0 itself, I do actually want to invite you all to a journey back to the year of 2020. Who here has been in crypto since 2020 or before 2020 even? Nice, quite some OGs around. But yeah, if you can remember, 2020 is the year where ETH2 is still a topic of discussion, which was superseded by proof of stakes or the merge, if you have heard of it. But yeah, back then, people are still discussing the possibility of ETH2 itself. It was also the year where Polkadot, you might have heard of the chain itself, actually launched their mainnet, which, yeah, time flies in this space. And 2020 was also the 2020 was also the year of DeFi Summer, if you were around. So Curve, for example, launched that year. Uniswap V2 was launched that year. A lot of exciting things were happening on chain, on Ethereum. And that also brought to an observation where, well, with all the interesting things happening on chain, they are all also fully public on Ethereum itself. And outside of Ethereum, or maybe on tangent with Ethereum, this was also the early days of CK. So this was actually a commit that I pulled from that year from Circom itself. That was how the docs looked like back then. And it was roughly also the years when Plonk is gaining momentum as an academic work. A bit of implementation here and there, but yeah, that was the year of 2020. So this brings us to basically two questions in the year. First of all, couldn't it all have been private? Why should all the interesting things happening on chain must be fully public, fully transparent for everyone? And couldn't the actual privacy works or the CK works be easier? Like, yeah, Circom is nice, but also it's like circuit crafting language. Plonk is great, so you don't have to worry about trusted setups, but there was barely any implementation, if at all. Which brings to the birth of Noir. This was actually the first commit in the Noir repo in 2020, and with one very simple goal. We simply want to do privacy. We want to make privacy simple to do. We want to make privacy simple to use. So privacy gets everywhere. Which brings us to everything everywhere. Throughout the years, there were a lot of development that has gone into Noir itself. From the first commits to the first version of Noir that we released. This is Noir Alpha that we announced at DEF CON Bogota. And we also announced Noir Beta that came in the year that follows. That was in DEF Connect Istanbul. And of course, we also released or pre-released Noir 1.0 last year at DEF CON Bangkok. Oh God, you have come up with some better naming. But yeah, throughout the years, there were a lot of changes that accumulated in the language itself. We started with the lovely fields that we all love, that always overflows. So we also added integers, where we can then bound numbers to actually work with. Also control flows, what you might be used to in other languages, if else, for loops, but also a lot more fun, even funner stuff, like operations. You can do comparisons. We have unconstrained functions, which is totally unique to the CK land. Most things are constrained, but sometimes you also want to jump into that unconstrained world to get some additional performance. Guillaume from the crowd would actually be doing a workshop over it later today as well. We also have generics, we also have traits, a lot of fun stuff from other languages like Rust or languages that you are familiar with that could be helpful in building whatever you want to do in CK. We also have profiler. This is actually Maxime talking about and sharing about a profiler earlier this year on how you can actually visualize your performance of your Noir programs, which helps a lot on actually diving deeper and optimizing your programs. And these are just like a brief look into all the things that have been accumulating on the Noir side in terms of what you can actually do with it, what it can actually help you do as well. And it's not just everything, it's also everywhere that involves Noir. So obviously Aztec has been using Noir as the fundamental language to power both its rollup, but also its smart contract. But we have also been maintaining the Solidity verifier for Noir programs, so you can also deploy your Noir apps on Ethereum or all the EVM chains alike. And the Arbitrum team has also been working on a stylus verifier for you to actually deploy Noir apps on Arbitrum stylus. The Starknet team has been working on a Cairo verifier. The Stellar Soroban team next door actually are also developing a Soroban verifier for you to deploy on there. The Field team has been working with HashCloak on a Sway verifier. The Solana team is also building a Graph 16 backend for you to use Noir on Solana. The World team is building a proof kit for you to maybe even use it on the World chain at some point. But yeah, there are a lot of places where you can use Noir on-chain, but at the same time also off-chain as well. BBJS has the verify function where you can basically verify any Noir proofs in a browser or in any JS environment. Or if you fancy verifying on mobile, there's also the MoPro team. Oh no, the slide cut out. But the MoPro team has also been working on a kit for you to actually do native mobile proofs, but also verification on your mobile phones. And there are also a lot of actually interesting examples that we can see that works fully off-chain as well. The CK Passport team is doing a zero knowledge proof of your passport that can totally work off-chain on a server-client relationship or even P2P. There's also the CK email team working on CK email primitives for you to prove your emails, which can also be verified off-chain. There's also the Fed Labs team working on Terra Escape, which is a fully offline P2P game that is played off-chain as well. There's also the Open Bands team doing a social platform where you can submit zero knowledge proof of yourself onto the platform to testify kind of your pseudo identity and make social posts around it. So with all the different places and all the different features, Noir sets out to basically do one simple thing, simply privacy, but now also privacy everywhere. Which leads us to the time that we are living in now. Throughout the last few years, things has changed a lot, both within the privacy space, but also in the entire digital space as well. We have been seeing, for example, the Estonian government putting more e-identities on chain as an example on the identity side. The Bhutan government has been working with EF on bringing their identities, national identities onto Ethereum as well through the initiative. EU has also been pushing the EU digital identity regulation framework to bring more identities on chain. So a lot of identities are getting on chain. At the same time, we're also seeing a lot of, well, we call it real world assets, but for real world people, that's probably just assets, bringing real world assets on chain. Western Union has been launching their stablecoin. Japan has been launching their stablecoin. Even Argentina or Latin America has been launching their stablecoins. Canada has been bringing stablecoins. The US has been bringing stablecoins on chain as well. So we are seeing a gradual shift of momentum of digitalizing a lot of what we might have been seen as important stuff, both on the identity side and also on the financial side. And with all the values coming on chain and coming to the digital world, in parallel to it, we have also been seeing a huge growth in the privacy sense of things as well. Of course, in our Web3 community, we have been seeing a lot of traction going on, catching up on the privacy side. We have seen like Railgun's deposits continuously flowing in. We have seen Zcash shielded deposits flowing in as well. A lot of interesting development on, well, both on the Noir side, but also across a lot of different other privacy projects taking space as well. And with even outside of the Web3 space that we are in, we're also seeing a great traction of privacy awareness as well. With the UK's introduction of the age verification regulation, we have seen, like, for example, Proton VPN picking up like 14 times traction growth just throughout those few days. We have also been seeing, well, the EU regulators planning to impose chat control, or basically encryption with backdoors in your chats or messages. And we have been seeing a lot of like grassroots momentum in pushing against that. And this is also a study or survey done by Deloitte, the consultation firm that you might have seen. It might be hard to read from afar, but it was basically asking like how willing or how reluctant are the general folks being willing to share the data with companies or services. The green part is like, I'm willing, and the gray part is basically very unwilling or, well, somewhat reluctant to share data with those services. And we can basically see like it grows from different facets, but the majority of the users aren't actually happy about sharing more data with the applications or the services that they are using as well. And hell, even our favorite YouTuber PewDiePie has been chilling about like Linux. How do you actually get to Graphene OS? Who here knows who PewDiePie is, actually? Okay. For the ones that did not have your hands raised, congratulations on your lovely life that you have. To the ones that actually raised your hands, congratulations to your lovely life as well. But after this week, do go touch some grass, please. But yeah, we have been seeing a shift of momentum on how people are actually caring about privacy as well. Like, it's not just us, you and me, shilling about privacy throughout the years, but people not caring about privacy is just a talk from the previous century at this point. Which brings us to the next chapter. What have we been cooking in the kitchen itself? You might have thought of or had impressions of like what the Noir team does. But what the Noir team does, well, most of us think we just like crash our laptops and get mad at it. But what we actually do, we have been cooking a lot of things in-house as well to basically close the last mile when it comes to privacy itself, as well as bringing privacy to people's hands. We have been, for example, fuzzing Noir the language. If you're familiar with fuzzing, it's basically, well, you can, in one-liner, it's like randomized tests, randomized generated tests for your code base. So we have been fuzzing Noir the language. We are not fully there yet. As you can see, we have a tiny red cross there that we still haven't cleared out, but we have been making progress. We have also been creating a fuzzer for people to actually fuzz their own Noir programs as well. So, for example, if you are building a Noir project, if you are planning to deploy it into production, strongly recommend you to actually fuzz test your program as well to make sure there aren't caveats that you might not be aware of. We have also been working with the Ray Labs team on getting, starting off with Noir programs being formally verified through the LAMPay project. Formal verification, if you think of it, in simple words, it's like mathematically proving that your program is right, in addition to, well, the traditional side of like fuzzing, testing, auditing, etc. And we have also been tightening up our way of actually gathering vulnerability reports from the community as well. We have recently set the GitHub security advisory process up on our GitHub, so anyone can actually report privately to us on bugs or vulnerabilities that they have come across, which is helpful in actually responsibly patching the bug, as well as privately communicating it with projects that might be affected first, and hopefully minimizing whatever damages it could bring. And we have also been working very hard for the last few months over internal audits of the code base as well. We have split the code base up into, I think, at least 10 groups, and this is like one group only. There are a lot of work that we have been going through on making sure we are doing what we expect it to do when it comes to Noir itself. And we also acknowledge that perfect is always the enemy of good. Like, we aren't striking for the perfect security, we aren't striking for the perfect version of Noir before calling it 1.0, but rather we are taking the approach of gradually and progressively securing Noir in-house as well as with the community as well. So with the Noir 1.0 launch coming up, we do also anticipate 2 more external audits, which we have already kickstarted, but has been progressing through on Noir the language to bring further kind of stability, but also confidence in the code base itself. And we also anticipate a lot more security initiatives to come. For example, competitive audits or open audits that you might be familiar with, or bug bounties as well that helps facilitate white hat reports as well as auditing of the code base. And we are here somewhat. We are working towards the 1.0's launch and quite a few of security initiatives that we'll be pulling through, which basically paints out the timeline that we are working against, but also at the same time, if you are actually building in Noir, or if you are interested in building in Noir, then what are the ways that you can actually participate in this timeline? Not just helping us, but also simply using Noir to achieve whatever privacy initiative or privacy application that you would like to use or do. It has been quite a journey since, well, Noir Alpha, Noir Beta, is it coming up? Noir Beta, Noir pre-release, and the current version of Noir. It has been quite a journey throughout the last 5 years developing the language. But how we see 1.0, it's the official starting line for we to actually race towards privacy, to actually race towards production readiness, privacy applications as well. And there are 3 immediate kind of things that you can consider working through. Well, of course, you are always welcome to stick around for NoirCon. We had some great talks earlier, but we have even greater talks coming up later today. Guillaume would be talking about Noir performance, how do you optimize your Noir programs at a lower level in a workshop here. And then the MoPro team would also be talking about how do you actually do native mobile proving with Noir later today in this room as well. Next door in the Aztec room, I believe what's happening right now is the DeFi Wonderland is going through, for example, how do you code your first Aztec smart contract with Noir. In the community room, what's happening right now is the Stellar team is also talking about how can you actually deploy your Noir apps onto Stellar Soroban as well. So a lot of amazing workshops and contents coming up in this afternoon still in this venue, but also at the same time, this is probably the best group of builders that we have gathered in this venue as well. So there are a lot of people for you to like brainstorm ideas against, to hack around ideas against, to build ideas around against as well. So do tap people's shoulder and start chatting as well. And the upcoming ETH Global throughout the weekend, there's also an Aztec track where you can hack around Aztec smart contracts or things that you might have been dreaming of building on Aztec. That would be a good opportunity. If this week is not the week, there's also the Cyberpunk Hackathon that is happening online from mid this month all the way to late this month, or well, December 1. There's also an Aztec track up there where there are also a few ideas on what you can actually hack around. So if this week is not the week, next week could also be your week as well. And with all the things that we have gathered for 1.0 itself, as well as what the community has been building, plus the new era that we are living in now, where there's more privacy awareness than ever, there's more demand for privacy than ever. Now is the prime time to actually build our privacy apps for our parents, for our grandmas, for our friends, and to bring privacy to this world. And it has been an honor for me to actually have worked on the project for so long, not just with the team, but also with all of you on bringing privacy to this world. And I do look forward to seeing you around this place as well, to brainstorm ideas together, to hack around with Noir, to hear your thoughts on Noir as well. And it has been my honor to present you Noir 1.0. And before we go, Noir 1.0 will be dropping 2026 Q2 next year. I'm Savio. Thank you all. Do we have time for questions?
Like if a person wants to contribute to NOR, like from outside Aztec, of course, do you have like a to-do list or a place in which you have like yeah, we have these problems, we need this tooling, please help us to build it? Where can I find that?
Of course. This list has always been an evolving list at some point. But yeah, there are definitely a few things that you could do depending on like your interests or well, your proficiency in Noir or in the stack itself. For example, simply improving Noir's documentation, to me, I would say that's already like a huge leverage that we can pull. There are a lot of content covered in the documentation written by me, myself, but also a lot of the engineers on the team, which might not always be the easiest way to consume the knowledge itself. So if you notice anything, we are always, well, Noir is open source from the ground up, so we are always welcoming PRs on improving, for example, documentations or READMEs, for example. And there are also, if you are more like cryptography oriented or more interested in the, for example, mathematical or algorithmical side of things, then libraries might be a good one as well. There are a great set of libraries today already with, for people to build out what they want to build, but I would imagine there being 10 times more ideas that could only be powered with certain libraries in place. So if you have certain ideas about libraries that you would like to build, feel free to build them and share it in the Noir Discord, share it on Twitter. We are always happy to amplify as well as share thoughts, cross thoughts with you as well. And if you are more a I guess, software developer-oriented personnel, maybe less crypto interested, or even, but we also like to make some impact in addition to just docs. I would imagine tooling being a very good part and very underexplored part at this point as well. For example, if you make things easier for people to import and export libraries, if you're making things for people to more easily discover different things happening in the Noir space, if you're making certain like menu interactions with Noir nowadays a lot more automatic, those could all be like great ideas for like tooling that could exist and help the bigger Noir ecosystem as well. But fundamentally, I would just recommend you to like try Noir out, talk with people in the space, and see where the gaps are. Those would be the fundamental principle for what you can actually help the bigger ecosystem to grow together.
How about small field support? Is it on the roadmap?
It's not officially on the roadmap yet, but that's definitely something we have been considering for next year. We have been very focused on shipping 1.0 first. But yeah, small field support and a bunch of other features we have been discussing internally has also been growing up on the list itself, where we would be able to tackle hopefully next year after shipping 1.0.
I participated in the previous Noir hack and it was really cool. Sorry to put you on the spot, but is there another Noir hack coming?
I don't know yet. Maybe. But yeah, we'll share more if we do have plans. Thank you.
Okay. Who do you think Noir is most suitable for? Which kind of profile and something like that?
Right. I would say if you are a developer or at least interested to become a developer, then, and if you are interested in doing privacy apps, Noir is for you. It's super easy actually to code Noir. Like I've briefly talked about CIRCOM. I briefly, well, briefly mentioned other CK stack as well. But a lot of people like come to me asking about like what do I need to know to start coding in Noir. I've always been telling them you only need to know like very fundamentally how CK proofs work. Like there's a prover, there's a verifier, and basically it's an interaction between them two. Once you get that, it's super easy to start coding. Noir is like very Rust-like. If you're familiar with the language or even not familiar with the language, it's quite easy to pick up as long as you are already somewhat comfortable with programming itself.
What will be the trade-off with more classical like Groth16 or Groth.js libraries that allow you to do ZK proof but without like the language layer? Is there a trade-off?
Right. So the way that Noir actually is architectured is there's Noir, the high-level language on top, but it actually works with different proving backends. Well, the caveat being some small field backends might be trickier to work with, but the architecture is aimed to be worked with different proving backends. So if you have seen, for example, Burtenberg, the proving backend, that's the proving backend that the Aztec Labs has been maintaining. It's based on UltraHonk, the proving technology. But for example, what the Solana team is building, it's actually a Groth16 proving backend for you to use as well. So you can actually switch between like different proving backends for different trade-offs. And to your question on what are the trade-offs, Groth16 is probably the golden standard when it comes to like proving speed, proof sizes. But the biggest drawdown that it comes with is that you have to do a trusted setup or a trusted setup ceremony for each basically version of circuit that you are building. And the problem with that when it comes to actually deploying applications or projects in production is, well, doing a trusted setup, every upgrade might be somewhat reasonable. Like if I'm upgrading from V1 of my app to V2, I do a ceremony with my users and bring things forward. But at the same time, if you're deploying into production, patching your app is also like super important. And I don't think any team would actually like to, for example, whenever they come to a small bug in the circuit and they want to patch it, they run the entire setup again with all the community involved. So that's why the Plonk technology came to place and gradually evolved to what UltraHonk is right now. For some specific use case, it might be slower in terms of proving speed. The proof sizes is also a bit bigger. But the beauty is that you no longer have to worry about a per circuit trusted setup. We just need one trusted setup that we can use from long ago, where a lot of people are already involved to secure it and call it a day and start building your app, deploying your app. So yeah, that's roughly the trade-off between those two. There are a lot more other proving technologies as well. If you are curious to learn more, I'm happy to talk more off stage.
Hi, thanks for the presentation. What kind of tooling you think could be helpful for the Noir ecosystem? And do you think it is necessary to have some tooling related to Noir with a specific blockchain?
Right, that's a good question. I can start with some, I guess, brief ideas on simply vanilla Noir tooling. We had an early version of the debugger, but it has also been falling out of date. So getting the debugger up to speed to the latest version would definitely be great on actually like going through your programs, debugging your Noir programs. I've also gradually been hearing more about how difficult it is to discover and make use of different libraries as well. So I briefly mentioned it just now, but for example, a very nice looking package registry with a package management system could be nice for people to actually know like what are the things available, how can I actually use them or more easily use them as well. And then there are also tooling on, I lost my track of thought there. But yeah, those are some of the like vanilla Noir tooling that could be useful. For the like on-chain part, to be fair, it's already quite simple. Like the proving backend, for example, using Burtenberg as the example, you have the Burtenberg backend, you generate a proof out of it. If you want to use it with a chain specifically, you only need like a very simple either SDK or a CLI tool that generates a verifier for the Burtenberg proving backend, deploys it, and then helps people to like I don't know, transcode that proof into the smart contract syntax that is needed and get it verified on that chain specifically. That part, like if you are a somewhat proficient cryptographic engineer, would only take, what, a few days of work to get a verifier in place. Of course, it would take a bit more time to beautify the thing, to flesh out the thing. But yeah, it should be relatively simple to do if you are going across chains as well. So yeah, if you have ideas, happy to talk more off stage as well. I think that's all the time we have. But yeah, thank you all for being here. Next up, Guillaume will be doing a very nice workshop that Jake would probably introduce. So I will leave the stage to them.
Awesome. Thank you, Savio. So did want to say we have Guillaume's session that is just about to begin. In the meantime, wanted to let you guys know, I mean, we were really excited to have this session where we share the Noir 1.0 roadmap. We've been working on Noir for many, many years now, and getting to share updates around when the language will be completely audited, ready for production use, was really excited for it. It was really exciting for the whole Aztec team. So did want to also let you guys know, we, as a part of the Aztec token sale, the Noir community has been a massive contributor to Aztec's production for many years now. So we already did manage to whitelist essentially everyone that has visited a NoirCon in the past. And wanted to let you guys know that all of you will be eligible to participate in the Aztec token sale as well. So we'll be following up with some emails. If you guys wanted to share Ethereum addresses, then that will give you access to participate early before the sale opens to everyone on December 2nd. With that said, we've got Guillaume's session in about a half hour, in exactly 29 minutes at 3 p.m. We'll have the final 2 sessions as well that will be going on in the other 2 rooms. One will be a session from Zcash on onboarding to Zashi, and the other will be a presentation from the ZK Passport team, who have been longtime Noir contributors and who we are also using to perform the not KYC, the ZKYC process for participating in the Aztec token sale as well. So with that said, it looks like we're getting all set up, and I'll leave it to Guillaume.
Hello. Thank you for being here. So I'm going to present, trying to give you hints on how to write efficient Noir code. But first, let me explain the title, because you should not write circuit. So I did that because when we were developing Noir, our motto was write code, not circuit. And so that like anybody can generate zero knowledge proof, and you don't need to be a cryptographer. You just need to know how to program. So that was the idea, but knowing, so what do I mean by circuits? So like circuit is the output of the compilation of a Noir program. So Noir is writing the circuit for you. You don't have to care about that, but it's important to know what it is doing so that you can write efficient Noir code. So we need to know what is the circuit, basically. Okay. The good news is that a circuit is a very simple thing. Sorry? Okay. So it's just a set of equations, like living in a prime field. And these equations describe the computation that you want to prove. So it just literally a bunch of equations. So it's very simple, in fact. In the context of Noir, we have also more in the output of the compilation, what we call gadget, or what in the context of Noir we call black box functions, which are stuff that is implemented. It's like it represents a small computation that is implemented by the proving system, and it's implemented like much more efficiently if you wanted, rather than doing it like using a generic circuit. So these black box functions, usually they are done using lookup tables. So lookup tables are a very important primitive of cryptographic primitive. And this is how you can access to this kind of primitive using Noir. We will see some example of that later on. Okay. So this is a very simple example. When I want to multiply a matrix by a vector, a 3 times 3 matrix. So like the multiplication, matrix vector multiplication is very simple. So like you say, okay, this is an equation. I can do the same for the second coordinate and so on. So I already have my circuit. Well, not exactly. The trick is that in your equation, you need to have only one multiplication. So we call this equation with only one multiplication, we call it a gate. And so how do you come from this to this? You need to create intermediate variable for each multiplication, then you can sum the result. Okay, so what we learn here that a multiplication costs one gate. Okay. So yeah, if you want, you can try the example. It's very easy to install Noir. I put some QR code, but you cannot install it on your phone. So just because it's nicer with the QR code, but no, you really need to follow the link, and it's very easy to set up if you are using Linux or a Mac. If not, then I don't know. It would not be easy. So this is for Noir, but you need also our proving system, which is Bartenberg. We call it BB. But installing it is also very easy. Okay. So this is a matrix multiplication example. So if you are not familiar with Noir, you see that it's very straightforward to code with Noir. So it's a Rust-like language. And here I added a command line that we will be using. It shows you the circuit size, so the result of the compilation, the number of gates that you have. So it also tells you the number of ASCII codes, which is an intermediate compilation step. But what really matters is the circuit size at the end, so 66 here in that case. And you can see that also we have just 3 coefficients, so the number of opcodes is only 3. But in reality, because of this like one multiplication per gate and so on, we have more. I don't know why it is 66, frankly. It should be like less than 30. But I didn't investigate. I think 66 is a good number. Okay. So we have seen what we can do with a circuit. Now, what cannot you do with a circuit? Well, you cannot do integer arithmetic. Like if you want, for instance, to compute the average of 2 numbers, you say, oh, good, I've got my equation. I don't need Noir, I can just use this in my circuit. Well, no. This computation is not the average of the x and y. And the reason is because 1/2 is not 0.5, it's a big integer number. We are in a prime field, remember, okay? Another thing that is not easy to do is a comparison, because it's not an arithmetic operation. So like everything that you cannot do in a circuit, you need to emulate it, and this is very costly. So fortunately, for comparison, we can use black box functions, which call it the run check. It's a very, very well-known cryptographic primitive. So run checks allows you to assert the bit size of a number. So in case of comparison, you would need like to do 2 run checks and a few arithmetic operations. So what you need to remember is that a run check costs between 1 and 10 gates, depending on the bit size. Okay, a circuit also doesn't have any memory, because it's only like numbers in an equation. So also this needs to be emulated, and this is horribly costly. But we have also a dedicated black box for that. So and yes, you don't really need to worry about the black box because like Noir will lay down the correct black box for you. But what you have to remember is that memory operations are costly, even with the black box. So if you want to do a read, it will be 2 gates, more or less, and a write would be like, in average, 4.5 gates. Hello? Okay. So why do I say dynamic read and dynamic write? It's because like if you want to access your memory at a constant index, an index as you know, like 5, 8, whatever, usually it can be optimized out. And one more thing, we need to pay for some initialization costs, which correspond to the array size. So even if you have only one dynamic read, it will be 2 gates plus number of elements in your array. And also these numbers are only for arrays of simple type, like numbers. But if you start to use composite type, it will not be the same number, so would suggest that you want to avoid that. And of course, what you don't have in a circuit is control flow statement, like using if, loops, break, continue, function calls. Okay, so all this needs to be emulated, and then it will be costly. Okay. So what we have learned here is that writing circuit is difficult and error prone, and circuits are not really efficient. So like one of the reasons also is that this integer arithmetic versus prime field. So when you want to do like normal computation with integers, it needs to get emulated by the field. But then you need to remember that you are executing this on your computer, which is like a binary computer, like using bits. For instance, like register of 64 bits. But our fields are much, much bigger, like around 256 bits. So then this will need to be emulated again by binary computer. So you have to do this kind of double emulation that is at the end very slow. Okay? Okay, but the problem is that in Aztec we want to use Noir for private smart contract. That means contract like programs that run on your device because you don't want to give your data to anybody else. So you just want to generate a proof and then say, okay, my transaction is correct, you can check the proof. So it must run on a personal device like a phone, so it must be efficient. So we need you to write efficient Noir code. And how to do that, given that Noir is creating circuits that are slow? Well, the answer, in fact, is quite simple. If using a circuit is slow, let's not use a circuit. And for this, we have this concept of unconstrained functions in Noir. So I say it's a unique feature, but like it's not unique. Like it existed well before Noir, so like it's not unique at all. But I think that the implementation we did in Noir is very good, like very well integrated. It's very easy to use, and yeah, you just add unconstrained keyword in front of your function, and that's it. So what can you do with this unconstrained function? So an unconstrained function is saying to Noir that, okay, this computation, do not put it in a circuit, put it outside the circuit. So that means that the cost is 0, like in terms of number of gates. Okay? Then what you need to do, of course, is to validate the result that you get that is computed offline, like outside the circuit, I mean. You need to validate this in a circuit, of course. So you still need Noir. Okay, so we'll see a very simple example, like the classical one, like how to do a division. So if you want to compute a division inside the circuit, how you would do? Like a division we are in a prime field, remember? So division, you need to multiply x by its inverse, the inverse of y. And the inverse, you can get it using the Fermat's little theorem very easily. So here P is a prime number of the prime field, like the characteristic of the field. So it's a very big number, like more than 250 bits. But fortunately, this can be computed efficiently using the famous square and multiply algorithm. But still, it requires log P multiplication. So to compute this, you will need at least 250 multiplications for just one single division. So it's kind of costly anyway. So can we do better? So yes, of course, with unconstrained functions, which is kind of straightforward, but maybe not. So yeah, this is something I'm trying to explain to my daughter for so many times, she still doesn't get it. But yeah, if you move the y to the other side, then you have a multiplication. Come on. Okay, so how can you do it in Noir? So yeah, you don't need to do it in Noir because Noir is doing it for you, but still, if you want to, you can still do that. So you can use an unconstrained function. You should just say that it's unconstrained. I call it divide, and then this is doing the real computation. And then we just check in your circuit. So main is is the circuit that you are going to compile. To use the unconstrained function, you need to specify that with this unsafe keyword that tells you that the result of this function is not proven, so it can be anything. Okay, no problem, because I will assert that this relation is true. So this is happening in a circuit. And when you use unconstrained function, you must be very careful because you need to think about all the edge cases. In that case, the edge case is when y is 0 because you are not able to divide by 0. So, okay, no problem. I just assert that y is different than 0, and that's it. So this costs one multiplication. This is another multiplication as well. So and maybe another one to return another gate to return the result. So like it costs 3 gates, and that's it, instead of 250 multiplications. Okay, so quite nice, no? So now I'm just going to give you, trying to give you some intuition on how to do that with more example, and that's it. So another example, which is also simple, is what if I want a function that finds an element inside an array that is sorted, okay? So the simplest solution will be to do a linear scan. And when I get to my element, I just return it, okay? So, and that doesn't work. And the reason is here we are doing a early return, which is a control flow statement that doesn't work in a circuit and that we do not emulate because if we would do it, it would add a cost, and it will be like a kind of invisible cost. So we don't want that. We want you to be aware that okay, this is not possible. How to do it differently? So one way to do it differently is to go over the whole array and then just check when we reach our elements, store the result, and then return the result. So, but that means that there is no, even if my element is the first one, you will process the whole loop. So this is an important point when you use an algorithm in a circuit, in Noir. You must remember that the cost will always be the worst cost of your algorithm. Okay, we know that we can do better. And the classical way to find an element in an array is to use binary search, which will be a log n cost. Then, if you try to do that, what will happen? Because here we have recursive function calls. This doesn't work in Noir as well. So function calls are emulated. That means that they are inline into your circuit. And if you call yourself, then of course it doesn't work well. Okay, so that's not a very big problem because you can always write an iterative version of a recursive function. But even if you do so, here the benefit of the binary search is that you have your array, you split it into two, and then you only search in the relevant part. But remember that if is a control flow, so it's emulated, and how do we emulate it is by you need to process the two branches. If you process only one branch, and it will not be zero knowledge because you will know in your circuit, oh, we are only executing this branch. So we need to execute the two branches. That means the gain that you do by this trick is completely cancelled because you need to process the two. So like this binary search will be linear time, it will not be log n. And because of all this overhead, it will be worse than the previous linear scan. Okay, still can we do better? Yes, with unconstrained functions. So here the idea is to do, okay, no problem, I will do my binary search outside the circuit using an unconstrained function. And then I just assert that the result is okay. So I assert it here. I hope you can read it. I'm not sure you can read. Yeah, more or less. Okay, so I just assert that the index given by the unconstrained function correspond to the element I was searching for. But here again, we need to pay attention to the edge cases. So this is fine when X belongs to the array, but what if it doesn't belong to the array? So yeah, in that case, we need to handle this case as well, else it will not be safe. So this is what I do. This is why I need all this. So like basically, either X is outside completely the array, so I check this, or it's inside, and then if it is inside, it must be between two elements of the array in terms of the range. Okay? So this is what I do here. But it still like doesn't change. There is no loop here at all, so I just do 1, 2, 3, 4 assertions, some comparison, and that's it. So it should be like a constant cost, right? But it's not what I've wrote here. So do you know why it is not constant cost? Why is it a linear cost? So remember what I told you. Here we are using an array. We are reading at a dynamic index into the array. So that means we have to pay for the initialization cost, which is n in that case. But still, this is better than the linear scan because in the linear scan case, like for every step, we do all this, which is a comparison and a if. So this will cost at least 3 gates per step. So the cost will be like O of 3n, something like that. Whether here, the initialization of the array is exactly n, and then we have a constant overhead. So it's better. All right. So now we know how to find an element in a sorted array, but my next question is how do we sort an array? So you may remember this interview with Obama. So what is the most efficient way to sort an array of with lot of numbers? And yeah, you should not use bubble sort because bubble sort is quadratic. The good point about bubble sorts is that where can we find it? I don't know. Shit. Okay, we'll see later. So what I wanted to show you, I don't want to break the setup, like is running the Noir profiler with this and the previous one, and then you can see the number of gates and what type of gates there are. And in the previous one, here, you don't have any dynamic memory operation. So all the array access are optimized. And the cost is, I think it's 50,000 gates for 100 array, an array of 100 elements that you want to sort. And here the cost is 3 times more, and because of, like here you are doing dynamic access on your array. Okay. So again, we can say, okay, but we can do better. We can use n log n sorts. So here I took the example of merge sort. Merge sort is very simple. So you divide your array in two. You recursively sort each part, and then you can merge the two because they are sorted in linear time. Recursion doesn't work well, as we know. So we will need to get to an iterative algorithm, and then it will not fit on screen. So I just brought here the linear merge, so the first layer. So we will need to do log n of these operations. And still you can see, oh, there is a lot of if, there is array access and so on. So here, like a good idea would be, okay, to see what do you get with the Noir profiler. And what you would get here is, I think the cost is around 10,000 gates, but just for one layer. So it doesn't compare well to even the bubble sort. Okay. So obviously the correct way to do sorting is to use unconstrained functions. So let's see. So the idea is that you sort your array outside the circuit, and then you check that the result is correct. Now, how do you check that the result is correct? Well, one part is easy, is to check that the result is sorted. This is very easy. And we can see that this is linear. I just go over all my elements and check that one is bigger than the next one, the previous one, sorry. All right, but that's just half of the story. We still need to know that the elements in your result correspond to your initial array. And what does that mean? That means that your initial array and the new one, the sorted one, must have the same elements. So that the elements may have been permuted, but they are the same. They come from the same set, okay? So this is a kind of permutation check that we need to do. So how to do that? So for this, I'm using this unconstrained function that gives me what I call the sorted indices. So what I mean by that is that if my smallest element is index 3, for instance, then this array will start by 3. If the second smallest one is index 8, then the second element here will be 8, and so on, okay? But this is totally unsafe for now. So what I need to do here, I check that every element of these sorted indices correspond to 1, 0, 1, 2, up to n minus 1. So here, using another unconstrained function, I prove that this array contains all elements between 0 and n minus 1. And since its size is n, then it is exactly this, okay? So, sorry. So what I have proven here is that this array is a permutation of elements from 0 until n minus 1, and that's it. Okay, now I need to compute in circuit the result using these sorted indices, which I do here. Okay, and this proves that my result, the element of my result correspond to the initial array. All right, and then the final step that, as we already saw it, is to check that it is properly sorted. Okay, so now you can see that we have 3 loops over my over 0, n, and like inside we just do a small assert, just 3 assert. So the cost here is linear. So we are even better than quicksort, merge sort, or whatever, which is kind of cool, no? I think. Okay, of course. There is no magic, there is no free lunch. Like even at Dev Connect, you have to pay for your lunch now. So you need to sort at some point your array, really. And this is done inside this function, get sorting index. So how does that work in the stack? So you have your program, you compile it with Noir, which gives you the circuit. And it will also give you the kind of assembly code of all your unconstrained functions that you are using. And then you need to execute to get your witness assignment. You need to execute your program. And at that time, Noir will run your unconstrained functions. So it will sort the array at this time using the code that you provide. So you need to, like here, do not use bubble sort because the execution will be very slow. It will be quadratic again. So you need to use efficient sorting here. Okay, so you need also to pay attention to that. Even if it is outside the circuit, it has some impact during execution time. Okay. Yeah, so this is this graph was done using the result of the Noir profiler that I didn't show you. So you can see that this is a logarithmic scale. So like bubble sort, of course, is very, very big. And this is not a merge sort, but only the first layer. So in reality, it's more than that. And this is what I wanted to show you. But here, like, we don't see much. So believe me, with the bubble sort, we only have run checks and arithmetic operations. So it's very simple and it costs 50,000 gates. For the merge, if you look in detail, you will see that we are using a dynamic memory operation, we are doing run checks, we are doing arithmetic operations, so it's very complex. And the cost here is 10,000 more or less, but just for the first layer. And with this unconstrained version, the cost is 700 gates, so much better. And we have a lot of memory operations, a few arithmetic operations, and we should have run checks as well. Okay, here we have run checks. Okay, so it's always a good idea to check with the profiler what you are getting, try different alternatives, see which one is better. Okay, so in conclusion, what have we learned here in this workshop? So if you have to remember one thing, is when you want to write a Noir program, then you use Noir to write a circuit that validates a result that has been computed in an unconstrained function. This is what you try to do. It doesn't always work. I mean, it always works, but it is not always the most efficient thing, but usually it's very efficient. You need to check and validate with the profiler. So in more details, we have learned that circuits are inefficient, yes. Multiplications cost 1, addition are cheap. Noir black box, they are good. They are lookup tables. With the profiler, you should focus on the circuit size, the number of gates. When you have an algorithm in a circuit, it will be the worst cost that you need to take into account. Dynamic memory comparison are costly. And for memory operation, do not forget the array initialization cost. If is not what you think it is, so use it with caution. Keep it simple and smart. So smart, I mean like you need to validate all the cases, all the edge cases when you use unconstrained functions. And also, last one, when you are using unconstrained functions, you should also try to optimize them, but this time using like normal programming language strategies, like normal stuff. You can use early return, use them. You can use if without problem, it will be good, and so on. Okay, that's it. Thank you. So if you have any question.
Yeah, about the unconstrained space, what is the language actually executed? What is available for you? It's not Rust, it's still Noir, but compiled to native bytecode. What are the features of the language in this specific context?
Yes, so it is still Noir, but it's Noir with more feature. Like you can, as I said, for instance, you can use an early return. If you use early return syntax in a Noir program, not in an unconstrained function, it will give you an error. If you use it in an unconstrained function, you will be happy. So it is Noir, but with more features. This program, yes, but it will be a Noir lib, but you can import. And then it's part of, it will be part of your library as well. So like it's fully native in Noir, in fact. Like that's why I was saying that it is very well integrated. This concept of unconstrained function in Noir, it's very, I think it's well done. So it's completely transparent. You continue to write Noir. And in terms of like more technical detail, so after, so you write it, and then it gets compiled to some assembly level code, which is like only our own assembly. And the reason is because in Aztec, we have private execution, but we also have public execution. And then for public execution, we need to run in a VM. Just to, in case of something goes wrong, we need to prove that the result is failing, rather than having a proof that you cannot, that does not verify. So that's why we need a VM. And so to have a VM, we need to have some bytecode. And this bytecode is the same as the one that we have for unconstrained functions. So it's our own bytecode, let's say.
Thank you. It is very interesting. I had a question about, you mentioned with the division example that is actually already optimized in Noir. Is there a way for us to know when it is already optimized by compiling it?
Not really. Like the basic stuff, you can expect it to be optimized, basically. More complex stuff, probably not.
Okay.
And then you can check on the profiler, if with the profiler, if it looks good or not.
Thank you. I wanted to ask, from someone that has some but little knowledge of Noir, you showed some examples of very complex functions that you use it unconstrained followed by asserts. So is it a good way of using that to run away from very complex and costly functions, or is it not?
So yes, so that was the point of my presentation. So it will not remove the complexity. The complexity will still be inside the unconstrained functions. So you need to write this code. It's just that this complexity will not run inside the circuit, because we have seen that inside the circuit it's much slower. So that's the idea. Like you move the complexity outside the circuit, and you just check that the result is okay using these asserts. Yes.
I had another question about the unconstrained part. Is there any privacy concerns because you're outside of the circuit?
No concern at all, because it's done by the prover. So like there is no problem. It's done by the prover. When you execute your program, you are still the prover that is doing that, and this will generate all the witness, which means the result of your unconstrained functions will become a new witness, but a private witness, not a public witness. So it's fine. And then these witnesses will be used to generate the proof, and in your proof you don't have them anymore. You don't leak any data. There is no privacy problem at all.
The only problem should be forgetting about the asserts. That is the only concern that may happen, may go wrong. Like that you do the unconstrained function, but you don't verify that it's computed. That it will be the only. Sorry, that will be the only possible issue from the side of the developer. Like that you execute the unconstrained function, but you don't do the assert that the computation is valid.
Okay, yeah. If you miss some asserts, then it's a problem, but not from your privacy. It's a problem for the verifier. Maybe So the verifier is not verifying the correct thing.
So the unconstrained execution environment is optimization, and it happens at runtime. I think in other ZK systems, the paradigm was more like to execute everything entirely beforehand and put the result or the pieces you want as public or private input of the circuit you are building. It's kind of a different but similar purpose way of doing things. Is it still useful, like this way of having another implementation of your program and compute it beforehand in like regular Rust environment or Python environment, and then like give the interesting part as public input?
Yeah, so it's similar concept. It's the same. The benefit of doing using a Rust, for instance, program, it will be speed. It will be faster than executing it in our assembly code, our own assembly code, because then it's another layer. Like we need to execute it, to read the code, to execute, etc. It's not like it will not be native compilation of the unconstrained functions. So it's a kind of a VM that we use for that. So the only difference will be speed, but then it's much more easier to use, and it's well integrated into Noir. Sure, I guess. Yeah, we need to see with the organizers. But yeah. Okay. Thank you then.
Okay. Hello, everyone. Yeah, so we are good to go and start to build our first ZK Noir mobile app. Okay, so if you're ready, we'll get started. So notice that this will be a workshop and talk like mixed style. So things like, I think, not sure, who here have developed on mobile before? Ah, that's awesome. Yeah, so there's some prerequisites that you have to install before that. So we're trying to like give people some time to install it. So in the meanwhile, while people are downloading the prerequisites, we'll try to walk through what is MoPro in high level, and also some new features we have, some cool projects we had before, and then we'll jump to the workshop itself. So my name is Moven. I'm from PSE, Ethereum Foundation. So MoPro, yeah, so this is today's goal about the workshop. Yep, so if you haven't installed the dependency yet, so you can, these are the things you want to install. And I think the first column is kind of missing. So if you are using Android, you need to use, you can download Android Studio, and you can directly go to their official website to download it. And if you are using iOS, you can download Xcode, which is live on App Store, so you can directly get them. Let me see, yeah, it's a full version. Okay, not sure why it's disappeared. Yeah, so we recently done a lot of things for cross-platform mobile development. So in order to get the first-hand experience, we recommend you guys to try Flutter or React Native for this workshop. So it does require some prerequisites. So if you haven't downloaded yet, like feel free to go to Flutter's documentations or React Native one, yeah, to get you prepared. And last but not least, make sure you install MoPro CLI. It will help you like to start your smooth process on building mobile ZK app. Okay, so if you have like further like things or you want to follow the documentations, you can also go to MoPro's website for that. Okay, so why people are install the prerequisites? I want to introduce like what is MoPro in high level. So it's shorthanded for mobile proving, and what we want to do is that since there are some scenarios, especially in client-side proving, we want to keep 100% of our private data in the device we can control. Yeah, so that's why having the ability to have your mobile be able to do proving is very important to us. So we noticed this gap exists in the theory and realistic side. So we try to build MoPro to both enhance the developer experience and also the user experience. So that's MoPro, what we aim for. So our target is to help developers or projects to build privacy-preserving mobile app. Yeah. So actually, it's quite very easy to use it. So only like 3 key comments you guys have to use in this workshop today. So first of all, you're going to need MoPro init. It's just like init a MoPro project, which is essentially a ROS project. So inside of it, it have a library where you can define what kind of functions or like business logic you want to expose to your mobile interface. Then we'll use FFI, like foreign function interface, to port this ROS binary to mobile so that your mobile native platforms or languages like Kotlin or Swift can understand and directly access to these like ROS functions. Yeah. So we use MoPro init to create this ROS library, and once you define the functions you want to expose to, you can go for the second one, which is MoPro build. So what MoPro build do is we will generate the bindings for your exposed ROS functions. And moreover, like we have many functions about it. So if you are using like native solutions, we have Kotlin and we have Swift. But more important, we recently integrate FFIs for cross-platforms like Flutter, we use Flutter ROS bridge to like eliminate a lot of glue codes that requires, but also like have React Native APIs inside of it. So I believe it will be a really nice developer experience. So we'll try that later. Yeah, so now you have the ROS library, you have the bindings that you generated for it, and the final step is Mopro create, which will help you scanfold a template app so that you can start building your mobile applications in no time. Yeah, so like also we have like native one and cross-platform one you can choose to. So very simple, just these 3 steps will help you start building your ZK applications on mobile. Now I'm going to walk you through some examples projects over here. So first of all, I think since you are in Aztec crowds here, people are amazing, and I think most of you guys have heard of Stealth Mode. Yeah, and we actually built a mobile version for it. So it uses the same things underneath. It's like ZK-JWT that is written in Noir. And then we can prove this JWT using Google Auth, so to provide a really like smooth UX. And also you can prove that your organizations without revealing the post. And also you can verify, like user can verify each message is actually comes from the specific email address that these users posted from. Yeah. And also, like we have an interesting feature, which is the internal chat within organizations, so that some chat, if you're from these email domain, then you can have the access to see this internal chat. And also, one more thing that we want to highlight is about the UX on mobile. So if you can, if you have ever used Stealth Mode before, you'll notice that what you post is like pure text, right? But in mobile, we can add additional parsing about it. So we can actually parse the Markdown syntax so that you can have like format message like this, and also some tables, and also you can include images or like links inside the Stealth Nodes. So it's like directly extend the feasibility and functionalities of Stealth Node. Yeah. So if you're interested in it, it's also open source. You can download it and play, and also it's on test flight, so you can like download it on your iPhones and get the experience out of it. Okay. Next is that I think in the mid of this year, some people built this proof of geolocations where you can prove that you are within a certain distance that the circuits want to verify. Yeah. So circuit itself is quite simple. It first starts as a circuit, but I think there's a lot of people like translate it into Noir. So this is a really fun topic, in my opinion. And one big challenge for these applications will be like, how can you combine your mobile's GPS data directly port them into the circuits so that you can like make sure like users not cheat about it. But imagine that if we enable this, like there's like additional check for the maybe host of the event to verify whether if these people is like near around the venue while they're checking, or there's like many other applications will derive from this. Okay, and the next one will be the Solidity verifier in order to unlock the on-chain verification. So in Mopro, we support like Circom and Noir for this. Yeah. So not sure whether if everyone plays around with Noir's on-chain verification before. Anyone has? Not yet. Okay. Okay, that's great. So we also provide this template so that people can not only generate the proof offline, but also you can use this proof to send it to the smart contract and verify it on chain. Yeah. So with this template, I think later I'm going to show you a live demo about this. And also, if you're interested about it, you can follow this repo and try the Noir version. It will be very fun. But one thing, one heads up is that we only update because Noir and Baritone backend is like update really, really quick. So we log into a specific version for this. Yep. So make sure you go to the repo and give it a check. Okay, and that's pretty much about Noir part, but also there are something that we feel exciting and we want to share with you, that running ZKVM on mobile is actually possible. So this example is RISC-0. We put them integrated with MoPro and build a template app for it. So you can see the left-hand one is a very raw one that we directly derive from RISC-0's template. And the middle one is that we try to implement ECDSA verifications within RISC-0. Yeah. So this is quite cool experiment, and the result turns out it actually works, but it has long execution time. I think our benchmark is close to 90 seconds for the ECDSA proof, but I think there's a lot of ways to improve that. And on mobile, we have some tweak that we can do for this kind of scenarios. For example, you can put these long generations of proof into background service, so you can even generate a proof while you close the app, and you just put it in your pocket, and once it's done the proof, it will notify you. So things like that is possible on mobile, and I think it will be the first step of running ZKVM on mobile, and I think this direction will generally greatly improve developer experience on mobile when they are trying to build a ZK app. Yeah, so we'll see. We're very excited on how this direction will evolve. And there's a cool one. It's called MobiScale. So I know that Theo is next door introducing face match. That's quite interesting. And we also received a hackathon project from East Global this year, doing this similar thing. They want to match people's face with their identity. Yeah. So he do it inside the TE to run the face match algorithm, and they use the NOR to verify the attestation generated from TE. So this is quite interested about it. And if you are curious about how does it work, you can also go to ETH Global page to check it out. Also some cool stuff, some ZK-Nox team has built this project called Zkeeper, where they have several features, and I think each of them is very interesting. So first is that they have turned the wristbands of your ETH Global wristband into a signer, and then implement a post-quantum access control with EIP 7702 to do so. And last but not least, they have a raw version of NAR integration, which is super cool. And now we are focused on mobile, right? So the most important thing in mobile, I think, is the user experience. So ZeroSurf is from the last hackathon in New Delhi. And what it built is enable a browser to do age verification using NR@HAR, which is a verification protocol for India's Aadhaar identity. And it used deep link to achieve really smooth interaction. So I'm going to show you here. So hope the network is going to work. Awesome. Yeah. So you can see that when you go to some website and it requires you to prove that you are age of more than 18, and this demo used NR@HAR to generate a proof to show that okay, you have you hold valid identity that can prove that you over 18, and once you do that, it will redirect you back to the browser itself, and then you can see that the content is now unlocked. Okay, so we got projects that we built from ourselves. We also have projects that from ETH Global Hackathon, and as we keep building this ecosystem, we found there are some projects from the community. So this one is called Solidarity. It's live on iOS now. Let me adjust it. Okay. So it aimed to build a business card with privacy-preserving features inside of it. And it used like Semaphore Swift for group management. And I think the most interesting thing is that it integrates AirDrop. So imagine that one day you met other people, maybe in NOAACon 3 venue, you grab out your iPhone, the other people grab out his, and you're just like, hey, can you AirDrop me your business card? And boom, it just appears and stored in your Apple Wallet. And like with Semaphore built within it, you can send a message like to the similar group of people that inside the group, you can send anonymous message to them. Yeah, so this is very interesting. I believe there are still like fastly iterate through improvements. But I just want to show you guys that these mobile things with ZK integrated is like on the way. Okay, so there are a few things we will do after DevConNet. The first is that notice, if you can remember, we just said that you have to run mopro init to create a ROS library so that you can add the functions you want to expose to them, right? So actually this part, we think some people who are more familiar with mobile development, they might not familiar with this. So what we're planning to do is that we put the ROS build part directly within the build script of your mobile app so that you don't have to care about anything about ROS. You can focus on developing your mobile ZK app. And second is that now we have FFI for Rust. And it's also like very interesting thing to extend the functionalities to other languages. For example, we can go for use Go or C#. And with C# unlock, this actually can build a lot of like Unity games or other like synergy for it. So it's very interesting. And also Python, like potentially for some ML scenario. And we also like have these new things called mopro pack, which is like we want to help people to pack pack their libraries they built, and they can release it as a native package so that any other people, they can directly use this as SDK in mobile platforms. Yeah. So it's essentially enhance the developer experience. And last but not least, like I said, ZKVM can greatly improve the developer experience on develop a mobile ZK app. So this is also a direction we are looking to. So if you're like interested about it, I would suggest that later in the workshop, you can try to install these Rig0 templates inside your phone so that you can get the first-hand experience about it. Yep. And also, we think in client-side proving, like performance is one of the things that we care a lot in order to like make all of the scenario for users very smooth, so they don't have to wait 10 seconds like for proof generation. And one direction is that the GPU exploration. So if any one of you inside of here like would be interested in this project, or you have built similar projects on GPU that runs on your mobile before, like make sure to like talk to us after this workshop. Yeah, we would love to like get your opinion and to see how we can work this out and push the boundary together. Okay, I think that's pretty much about like the high-level view about mopro and what we're going to do like afterhand. So without further ado, I think we're good to go and start to build the first your Noir app on mobile. So raise your hand if you haven't installed Xcode or Android Studio. Okay, still installing? The network issue. Okay, no worries. So later in the work, if you want to build Android app, I think you can directly download the dependencies that we need. But I think Android Studio will provide the best, like the most easiest installations for you. Yeah, and since we'll start for the workshop now, so later on, if you have any questions, you can go for Vivi over there. Say hi. Hi. So Vivi and I will help you guys through the entire process of this workshop. Yeah. So I will give you guys a really high-level view on what we're going to do in this workshop. And if you haven't followed it yet, or you cannot get the dependencies installed right now, it's totally fine. You can directly go to our documentations, and you can try it. And maybe when you are in a place have better network connection, or you have some spare time for it. Yes. So what we're going to do is that first, get the COI ready, and then we were going to build a template app following these three commands that we introduced before. And so since this is, we are trying to build a Noir app, right? So make sure you choose Noir when you init the Mopro project. And next, you can choose either Flutter or React Native and when you're building FFI, and also create a template app for it. And now I think all the things will be good to go if you only run these three commands. And now you can plug your phone into your laptop, or just start an emulator so you can mimic a phone inside your laptop to run this app. Yep. And this will be the first step. Okay. So after you complete this step, there's a second part, which is more challenging. We want to introduce you guys how to update the logics inside the template app, so you can put what you are written, any expose function that you want inside of Mopro project. Yeah. So you can either add a new Rust crate, or try our another Noir app template, and then you can run Mopro build again to generate the new bindings for it, and run Mopro update, so that we will help you update this FFI to the correct space of your app. Yeah. And if you don't know what Noir app templates is available, you can try this on chain verification one. So yeah, so it used Noir beta 0.8 version. I think it's 3 months ago, and also the Beretenberg one. You need exact the same version to do so, because the Acer which have been compiled could be a little bit different. And but this is a very interesting version, so it already has some mobile-friendly features of it. So when you are in Noir, you will notice that if you choose Noir template, you can find out that there are some options you can tweak. For example, you can choose whether if this proof use catcheck or Poseidon as your Oracle hash. Yeah, so if you choose Poseidon, it runs faster in your off-chain verification. But in order to do on-chain verification, you have to use catcheck for Oracle hash. And also, since mobile is very memory constrained, average phone nowadays have only 4 gigabytes of memory. So it is very important to have a mild memory consumption, and Noir enables no memory mode. So if you find your programs quite big, you can also tweak this low memory mode on, so that it can run smoothly on your mobile. Though it will give you 2x slower, but it won't make the app crash. Yeah. So yeah, so let's get started on the workshop. Okay, let me move to here. Okay, so right now, it's a little bit small, right? Right now, first of all, we have to verify whether you have the CLI download. If you haven't, you can just run cargo install Mopro CLI, and you will get it to our latest version of 0.3.2. Okay. So once you have it, we can run Mopro init to create a Mopro repo for this. So since this scenario is NoirCon 3, so let's build a NoirCon 3 app. Okay. And just choose Noir as the thing we want to use. And one caveat here is that we do build extra support for proving system like Circum Halo 2 or Noir, but actually you can choose none of the above. So what will you get if you choose none of the above? You will get a really nice FFI wrapper so that you can port any functions like you want to compute MPC protocols, you want to compute FHE, you just import these Rust crates inside the Rust library of MoPro projects. Then you can also generate the bindings for them and make it run on mobile. So this is some caveat. Okay, so now you'll see that we have this MoPro projects generated. Let me walk you through what's inside. So like essentially only these things like this library.rs like matters the most. So you can see this default expose function right here. So you can just essentially import any like crates you want to use inside of this lib.rs, and then like invoke them within a public function. And on top of it, you only have to add this macro to ensure we have XSI like expose it to UniFFI so that when we are generate the bindings, it knows which functions is going to like expose to the mobile interface. Yeah. So just like create whatever functions you want and add this macro on top of it. Yeah. And it also supports some custom structure. You can also export this structure or data types with this macro. Yeah. So this is what we do over here. And there is also the Noir, like high-level APIs we've already wrapped. So you can like generate the bindings in a more user-friendly way. So if you can see that there's some like this on-chain booleans that you can like choose whether to go for cat check to enable on-chain verification, or like false to enable Poseidon as Oracle hash for faster off-chain verification. Yeah, and also this low memory mode that we previously introduced. Yeah, and okay, so that's pretty much about the interface you have to know as you play around with MoPro. Okay, so now we have it. That's back to the demo. So let's say you have already like add the functions you want to expose to mobile. So now we are ready to generate the bindings that port this Rust functions binary and generate FFI for them, and so that the mobile platforms like Kotlin or Swift can understand and invoke these Rust binaries. Okay. So that's from MoPro build. Oh, sorry. We have to go into the project first. So that's from MoPro build. Okay. And we choose release modes for the best performance, and you choose Flutter FFI. Okay, so just wait for it to compile a while. So while this is processing, I want to know if there's anyone like following this workshop. Awesome. So have you faced any problem yet, or okay? Too many requests. Thank you guys. You are a very warm crowd. So, okay, I think maybe like give it a second, or you can check the documentations when we back to a place with better internet. Sorry? So are you asking what's the difference during MoPro build? What's the difference of iOS, Kotlin, Flutter, and React Native? Okay, that's a great question. So each different platforms, I think, have its own like best suited FFI. So beforehand, like we only have Android and iOS FFI. So we have to generate we use UniFFI to generate the bindings for iOS and Android. And later on, if we are using some cross-platform framework like Flutter, we plug this to bindings into them. And we have to write some glue code to make sure that the Flutter understand the native bindings of iOS and Android. So that's a previous one. In the new MoPro, we integrate FFI for each different platforms. So we have, for Android and iOS, we use UniFFI. But if you can see right over there, let me try to score a little bit up. Okay, it's not oh, you can see, yeah, it's right over here. So for Flutter and React Native, we use its own FFI. So you can see that in this case, it identified that, oh, we are actually choose Flutter. So it switched from UniFFI to Flutter ROS Bridge to provide a better binding interface in this case. Yeah. So I would suggest that though iOS and Android bindings is a good option as well if you are building mobile app. But if you are using cross-platform solutions like Flutter or React Native, you can try to use its native FFI instead of using UniFFI. Okay. So you can see that it's compiling the bindings for it. It's right over here. Yep. Okay. So it is already built. And I want to show you guys what the binding looks like. So you can find that we have this MoPro Flutter bindings over here. And actually, it is quite lightweighted. So before, if we use UniFFI, it would generate the bindings generate the binaries for these Rust functions, which is quite big sometimes. So for example, if you are building a iOS bindings, sometimes it will be few hundred megabytes or even gigabyte level. But in Flutter ROS Bridge, we use 4 right now. It won't build the exact binaries when we are generate this binding. So it is lightweighted. You can commit them to your GitHub for version control very easily, and the binary will only build when you are running Flutter run, and when you're building the app, this ROS binary will be built at that time. Okay, so this is the bindings. And it helps us, it also includes a lot of glucose inside of it, so we don't have to write them manually. Okay. So is there anyone generated the binding? Not yet, okay. So that's all right. You can try this tutorial when you're in home. Okay. So now we have MoPro projects ready. We already generated bindings. The final step is create a template app for it. So that's from MoPro, create. So you can see that you can choose this many different templates. So let's choose the Flutter one. Okay. Okay. What's the issue here? Is it a network error? Okay, so previous error is network issue. Now we have it here. Okay. So you can see that we have this template Flutter app inside of it, and the main logic will be live in this library main.dart here. So you can see that it imports the binaries that generated by Flutter ROS Bridge FRB, and then also this exposed and ported functions from Rust right over here. And you can invoke them natively within Dart. For example, let me go to generate nor proof. Okay, so you can see that it is actually wrapped into the interface that Dart can understand, so that you can build this Flutter app very easily. Okay, so let's try to run this template. And before this, let me start the emulator. Let's run the iOS one. Okay. Perfect. Okay, now we have the emulator right here, so we can go for Flutter run. It will like automatically detect which emulators you're on. Oh, sorry, you have to go into Flutter directory. Okay, let's do Flutter run. So let's choose the emulator and wait for it to compile. So it might take a while, and that is also a benefit as a if you are using MoPro to develop the Noir app. So in the meanwhile, you can get yourself a tea or some coffee, yeah, or some snack. My personal favorite is like I will have a chess match in between this building time. Hi. Oh, yes. Uh, I think the circuit of geolocation is easy to implement. You have to check the like geo distance between 2 points. You can get the latitude data and longitude data from GPS, right? And you put them into constraint. I think the hardest part is how do you connect, make sure that the GPS data that received from the phone directly ported into the circuit without some contamination. Yeah, I think that's the hardest part, and I think some people has already explored that, but they don't have a great solution right now. Yeah, so proof is easy. You can just if you're like doing POC, you can just use some default data for that. But if you want it into production, you need extra works on make sure the GPS data is not like colluded. Yeah. Okay. Now you can see it's already built, and you will install the app inside your emulator. And one thing that I love Flutter the most is that it has like hot reload and hot stop feature. So it makes the development also very smooth as well. So it's actually not harder than web browser, like building a browser app. So once you have all the dependencies configured, I think it's like quite easy. And also you can build something with quite a good user experience with it. Yeah. So you can see that since it's a template app, we have like defaultly implement the interface for Circum-Hello2 and Noir. And in this case, we just go to Noir 1. And maybe let's say let's just change the public inputs to like November 20 and generate a proof for it. And then we can run verification about it. So you can see it's pretty raw. It's just a template application. So in the real production, you have to modify the interface inside of your Flutter app, specifically in this main.dart to like ensure that your UI and your business logic of the app looks great. So this is So this will be the first part of the workshop. And if you want to change any logic of the app, you can directly go to the MoPro projects library, which is where we expose the functions, and just add anything you want and generate the bindings again and run MoPro update to do so. So since we have some time constraint today, let me just run a real demo in my Pixel phone right here, so that you can understand a more a template app that runs Noir and with more functionalities. So let me just run this to port my to mirror my phone to laptop so that you guys can see it. Let's see, where is it? Yep, it's right here. Oh, okay. Oh no. Oh no, people are seeing me. Ah, no, sorry for it. Okay. Here we go. And okay, so this is like my phone, like in real life here. So this is a Noir app that we built before. It is the Wallet Connect one. So if you want to play around with this one, you just go to the GitHub repo and clone it, and just run Flutter run, and you can also start this as well. Okay, so let me disconnect the wallet first. I want to demonstrate something. So it is also like very similar like multiplier circuits, and you can just like generate a proof for it. And you can see the time. Not sure whether you can see the timing really clear. It's at the below. So it's around like 300 milliseconds. And if it's a catch-check proof, it's also under 1 second. So it shouldn't be long, thanks to we have the nice proving backend in Noir. And now you can verify it as well. It's valid. And we want to demonstrate the ability to connect to on-chain worlds. So we have this Wallet Connect with Reon's using their app kit. So let's connect MetaMask. Okay, can we connect it? Sorry. Okay, and we show the connect. So this thing is actually powered by Deep Link, so it can transit in between apps very smoothly. Okay. Okay, so you can see that now it's already connect. We can run this verify on-chain feature over here. Yep, so you can see that it works. Like, and the speed is according to like the connection of you or the RPC node that you choose. So I'm not sure if you can see that. It's around 700 milliseconds to verify the proof. Okay, so this proof is like 16 KB. So it's like mild size of the proof. Yeah. So this is the more like advanced one you can play around with. And for full feature of Noir app, you can also download Stealth Node mobile version and build it on your laptop. Yeah, and to play around with it. Okay, so this is pretty much about the demos for today. And so right now we are actually trying very hard to push, increase the people building mobile app in Web3 space. So I think people here are very care about privacy. You guys know how important it is, right? So if you want some privacy that people can use in their daily life, not only with their laptop, but also their phones. We need to increase inclusions and make building mobile apps with ZK more easily. So that is still gonna be the goal of MoPro is trying to do. Yeah, and also we are looking forward to push privacy in mobile community. So we are going to walk into Web2 world and try to have them know the importance of privacy and include more mobile native builders. Yeah, so thank you for joining today's workshop. I hope you have great experience. And if you are interested about it, you can also follow our documentation. We have very nice get started and some write-up and also some blog you can look into. And we are live on the Telegram group. So if you want to find us, you can go to the group and make sure you follow us on X for any latest update. So thank you so much.